Today let's discuss this LeetCode question 24, swap node in pairs. The question is, given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in that list node. So what it means is, if we go to the example 1, we are given a linked list 1, 2, 3 and 4. So we have to swap the second node with the first and the fourth node with the third, and we get the output we get is 2143. But in any case we should not be modifying the value in the linked list. So what it means is, we should not change the value of the first linked list node to 2 and the second linked list node to 1. So we should not change the value. We have to just move the linked list node itself. So let's go to the second example. So the second example is the head is actually none. And the third one is the linked list head has only one node. So there is only one linked list node. These are the three things. So let's quickly discuss this. Hi guys, let's start the explanation with the edge cases first. So what will be the edge cases for this scenario? So there will be three types of edge cases. One is when head is equal to, this is head is none. And the second one is when the head actually contains only a single node. Only single node is present in the linked list. And the third case is when the head contains two nodes. Means there are two linked list nodes. Two nodes. So in this case, what is the output for all? Okay. What is the output for when the head is none? The output should be none. When there is a single node, we have to return the single node itself. Nothing, no change. And when there are two nodes, swap them. So the output will be like 2, 1. So now we are clear like what are the edge cases that needs to be solved. Let's go into that happy flow path where we discuss how this linked list, we are going to swap the nodes in pairs. So let's take the example that is given in 1, 2, 3 and 4. So this is our given input. So how we are going to solve this is, we are going to create one output and we'll be creating a dummy variable. So let's say the dummy has value of 1. Let's create two reference pointers for this. One is dummy and the other is result. So let's put two pointers to this head, and I'm going to call this head as odd. So odd means it is like 1, 3 and 5. So this is going to be odd. And the second node I'm going to have a pointer as even. Okay. So then I'm going to store the even.next in a separate, I'm going to give a reference for this. The reference is going to be, I'm going to store it in the store. So because when we are swapping this even and odd, so in the input odd comes before the even, but in the output even comes before the odd. So we have to store this one, so to keep track of the linked list. So after doing these things in the output, the next we have to point the dummy.next to even. So here in this case the even is 2, and then we have to point the even.next. So this is going to be even. Then we have to point the even.next to odd. This is going to be odd. Then what we are going to do, we are going to do the same operation again. Since we have stored this in the store, we are going to change these pointers. Then okay, I missed a step. Let's discuss one more step here. Now let's move the dummy pointer till here. So this is the dummy pointer. Then the odd should be moved here. Then we have to move the odd. So let's do it in the input. So the odd comes here, and odd dot next will be even. So let's move this one as well. This one moves here. So now we got a track of everything. So this is just like a loop. So we are having the odd and even, and our dummy pointer is here. So this is again the same loop that is happening initially. So we had initially we had the dummy over here, the dummy variable here, and then we are swapping that even and odd. We have swapped that even, and here we had odd. Then we moved a dummy here. Then we are going to do for the next two nodes as well, 4 and 3. So we get 4 here and followed by 3. So this is how we are going to do it. So let's quickly code this up. Let's start with initializing the even and odd pointers. So odd comma even. Wait, just a second. Odd comma even equal to none comma none. If head is not none, then odd is equal to head. If odd is not none, then even is equal to odd dot next. So let's create a dummy node as well. Dummy is equal to list node of it is list node of 0. Okay, and then let's create one more reference for this dummy as well. Result is equal to dummy. Then let's run the while loop while odd and even. So we are going to run this while loop only when odd is not none and even is not none. So then what we are going to do, the first thing that we are going to do is like store the even dot next. So we are going to create a reference, store is equal to even dot next. Next we are going to point dummy dot next to the even. Then the next thing is even dot next is going to be odd. Okay, so we have dummy dot next is even and even dot next is going to be odd. And then what we are going to do, we are going to move this pointer dummy is equal to dummy dot next dot next. We are going to move by two positions. Then we are going to then do this from the store. We are going to pick this linked list and going to initialize odd and even again for the next iteration. So odd is equal to store if store is not none else none. Even is equal to store dot next if store is not none else none. Yeah, so we initialize this odd and even for the next iteration. Then we are coming out of it. In case this while loop will break if odd is not none and even is none. So only odd is a node and even is none. So in that case we have to store this dummy dot next to the odd value. Okay, and then we are going to return result dot next. Yeah, I think we are done. Yeah, let's quickly run the code. Okay, it is accepted. Let's quickly submit it as well. Okay, thanks for watching.